pound per square inch. So you have these units to convert from one pressure system into another. So I have a mass of 14.7 pound placed on 1 square of inch surface. So force which is exerted in this 1 square inch surface is equal to pressure of 1 atmosphere, which is 14.7 pound per square inch. So guys, what is going to happen if the pressure, if the atmospheric pressure is exerting pressure here on this side? And I have a gaseous system inside this bulb, and I open the valve. Is it fair to say if the pressure of the gas, is equal to atmospheric pressure, this is what I'm going to get. Case number 1, I will see the mercury on the left and right are equal together at the same level, My pen has stopped working, I don't know why. Okay, the pressure of mercury on the right-hand side should be equal to pressure of mercury on the left-hand side. That means the two height are the same on both sides of this U-tube. What happens if pressure is less than 1 atmosphere? If the pressure of this gaseous system is less than atmospheric pressure, obviously atmospheric pressure is pushed down the mercury to a higher column on the left. So what I'm going to see, I see a higher column on the left and lower column on the right. So that means the pressure of the gas, the gaseous system that we have here, which is connected to this bulb. If the pressure of the gas is less than atmospheric pressure, that means atmospheric pressure is less than pressure of the gas. The pressure of the gas is going to force this to go down, and the mercury on the right-hand side is going to rise. So this is the situation that you are going to see. This is the pressure of the gas. And this is the pressure of atmosphere. If pressure of atmosphere is less than pressure of the gas, so on the left-hand side, this pressure is going to push up the mercury. So we are going to have a difference between the two height of the mercury, which is showing how much the pressure of the gas side is larger than atmospheric pressure. What if I have a situation where atmospheric pressure is larger than pressure of this gas? So this is the atmospheric pressure. And can I say, let me clear my board. Can I say if the atmospheric pressure is larger, and this is the valve, and this is the gas, and suppose the valve is open, suppose that valve is open, this is the valve, pressure of the atmosphere is larger, it's going to push up mercury toward lower pressure. And also there is a difference between the height of the mercury on both sides, which is telling you that's How much atmospheric pressure is larger, so it is pushing mercury from right to left. This was supposed to be working, it's not working anymore, so that's why I had to do all this drawing. So what do we measure the pressure of the gases? And let's go to this side, to next side of the slide. Well, we measure the pressure in that atmosphere. And what is 1 atmosphere pressure? Is pressure which is equal to 101,325 pascals. So Pascal is another unit of pressure in metric system, very small amount of pressure. We also measure pressure, atmospheric pressure, in torr. Every 760 torr is 1 atmosphere, which is the same as mercury, 1 millimeter of mercury. In other words, if I want to say that, I can say 1 millimeter of mercury is also equal to 1 atmosphere. I'm sorry, 1 torr. So can I say 760 torr is also equal to 760 millimeter of mercury, which is equal to 1 atmosphere. So torr is equal to 1 torr is 1 millimeter of mercury. In fact, the unit torr is named after Torricelli, Italian scientist who made the barometer. There is another unit of pressure, is bar. It's a little bit larger than 1 atmosphere. By the way, you don't have to memorize these units. You'll get them on your exam. It's already on your exam table. And this is showing that 760 millimeter of mercury is 1 atmosphere. So it's showing the approximate amount of 1 millimeter of mercury. You're already familiar with pound per square inch, which is PSI. And as we said, 14.7, or even more accurately, 14.696 pounds per square inch is equal to 1 atmosphere. These are unit conversion factors that information would be given to you to convert from one unit into another. And if we study height of mercury in inches rather than millimeter, 29.921 inches of mercury is 1 atmosphere. So the height of mercury can be measured in inches, in millimeters, or in torr, and then you can relate that to 1 atmosphere pressure. So let's do this, guys. Use this information. If you have your book, find the page where you find relationship between these units, or right now open up your Canvas, go to exam table, use it to answer this learning check right now. I want to see who is the first, who is going to raise their hand first. Victoria, yes. Thank you, Victoria. Victoria got it. I'm waiting for some more people to get it. All right, guys, let's see if this makes sense. Can I say the downward pressure of mercury in a barometer is the same as the weight of the atmosphere? In other words, if weight of atmosphere wasn't equal to downward pressure, it would push up mercury to go higher on the left-hand side. So when these two forces are equal together, the downward pressure of mercury and air, when they become equal together, then you have an equilibrium height of the mercury. You can measure the difference between them and decide what the pressure of the atmosphere is. But these two must be equal together to get to the equilibrium. And also, look, the density of mercury is 13.6 grams per ml. Anybody remember density of water? Anybody? Density of water? Anybody? Is it 1.0 grams per ml? So do you see mercury is 13.6 times heavier than water? So why are we using mercury? Because of its larger density. Otherwise, the height, if we had used water, the height of the column or barometer would have been 13 times larger. So what is 13.6 times larger than 1 yard? It's very high. If you want to read a barometer which is using water, you have to call fire department to bring these huge ladder to go up about 3 stories higher to read the barometer. So barometer is using the heaviest liquid at room temperature, which is mercury. So you have minimum height of the column under atmospheric pressure. Do I make sense? Do you have any question?